Okay guys, this is going to be a fairly basic video, but this is going to be the first part in the component series. So what I'm going to do is I'm going to grab firstly just some very basic components. I'm going to go over what they are and I'm going to show you a few different styles of them. In further videos down the track, I'll explain what the different styles, how they differ from each other in terms of parameters, and we'll go on further from there to more complicated components like integrated circuits and stuff like that. So to get started, I think what I'll take is I'll take resistors. I'll take a power resistor, a variable resistor, take some just random different sizes of variable resistors and fixed resistors. Okay, so this here, this is what's known as a rheostat. It's got a whole coil of nichrome wire inside it and a wiper that's attached to this middle pin. The coil goes from these two outer pins, and as you turn the wiper, it moves it across the coil, which increases the resistance between this point and whichever point you're turning the wiper away from. The same thing here with this, except for the point that's in between these 2 points is a carbon track with a wiper rubbing on it. So these two also are carbon style variable resistors, but these are all resistors. These are variable ones. The next most common type that you'll find excluding surface mount. I'll do another whole complete video series on that. So through whole components first. So then you'll find your power resistors. Now these don't always just look exactly like this. You can get power resistors that sort of look more like this with longer legs, but anyway, then you've got your smaller resistors like a 1/4 watt resistor or a 1/2 watt resistor. So I'll just leave those components there. Can you guys see that? Yeah, cool. Just move that. That's a bit better. Hide that ugly paint spot. Beautiful. So that's resistors. Next up, and I should probably explain what resistors do. Sorry guys. So resistors are like the most simple component you could think of. Basically, if you can imagine electrons, power, voltage, however you want to think of it, current, whatever, a mixture of voltage and current moving down a wire. A resistor limits that flow. It's the equivalent of you grabbing your garden hose and pinching it and varying how much you close it or open it, which inherently affects how much water flows through it. That's what a resistor does. So, and it's not a size thing. Size is for their power dissipation, so how much power is flowing through them. The fact of the matter is these things are measured in ohms and watts. the watts is just how much power they can handle. The ohms is how much power they will drop. And that's, you know, a 100 ohm resistor will drop more voltage in current than a 10 ohm resistor. 0 ohm resistors are short. It's, you know, a very small, thick, short piece of copper like that. It's like 0 ohms. Right, next thing we'll go on to is capacitors. Now capacitors, again, come in so many different styles. You guys have seen on my bench, you have seen some ceramic ones and some monolithic ones. So some tantalums for you. I've got some special types of capacitors too. I don't know if I can actually remember where they are. Oh yeah. So these are some that you will see. We've got an MKT capacitor, a polyester capacitor, a monolithic capacitor, another monolithic capacitor, a tantalum capacitor, and a polystyrene capacitor. Now those are just some small ones. We also have electrolytics, which come again in the most crazy ranges of sizes, usually from anything around that size to this size. You've got them even smaller than this and bigger than this. Now capacitors, you can think of them as kind of like batteries that have the ability to suck up a charge very, very fast. Oops. And at the same time, dump that charge very, very fast. Now the difference between a capacitor and a battery is a battery can slowly absorb charge, but it can store a lot of it in terms of energy, and it can dish it out over a long period of time. A capacitor, whilst it charges up fast, it doesn't hold as much energy in terms of power, like watt hours energy over time. It doesn't store much of that. So whilst it can have a high voltage and a high current, that you can discharge basically instantly almost, it's only for a short period of time. So you can think of a capacitor like a super battery that can charge up and discharge really, really fast, but at the same time, it's going to go flat really, really quick. I think the next component we'll cover is diodes. Let's move these off to the side. I'll finish packing up later. So again, with diodes, they come in so many different types. It's just amazing. I'll get some of the common style ones that you'll run across. So common ones would be power diodes. And there's a smaller power diode. Small signal diodes. Zener diodes. So that's just a couple of different diodes. Now, what diodes mainly do is they let voltage or current flow in one direction only. So say you have an AC power source. The difference between AC and DC, by the way, is AC, the power is flowing in both directions on each wire. So as it goes up one wire, it goes down the other, and vice versa. So it's going like this. With DC, it's just going around in a circle. If you put a diode on AC, or in series with an AC source, it will convert that AC source into DC. So that's not the only purpose of a diode, but again, like I said, this is just the start of components, and you know, we could go on forever. It's like capacitors. I could keep showing you capacitors. Here's another style of capacitor. Absolutely massive pulse grade capacitor. Some sort of film sort of style inside, I'd say. Anyway, I digress. Oh yeah, and also whilst I'm on capacitors, I forgot to show you these style of ceramic capacitors. Or at least I think I did, I can't remember. Alright, so what have we covered? Capacitors, resistors, diodes. Alright, so the next part that you're going to see everywhere is going to be transistors. You'll get small signal types that literally look like this. It's really hard to get my camera to focus without something behind it. So they've got 3 pins, and they range from anything from that size. Again, not covering surface mount, because obviously that's a lot smaller. But in through hole, they come from basically that size, which is what's known as TO92 package. They start getting a little bit larger. Yeah, that's a good example. Sorry about the squeaky floor. So they start to get a bit larger, and then a bit larger again. And then they start to get even larger, and you'll see metal heat spreaders to get the heat out of them because they're high power devices. You can even find some that are this big. These are old school 2SC5200s for anyone that knows. The old school ones that had the 17 amp collector rating. Oh yeah, also you get other styles of transistors. So you get this style. This is a TO3 can, and you can get them also in smaller versions in a metal can. Again with 3 legs, obviously, because it's a transistor, it's going to have a base, emitter and a collector. But just some more styles of transistor. MOSFETs basically look the same as transistors. they also behave quite similarly, but you can't use them the same. For example, that's a MOSFET, and I'm sure I'll be able to find a transistor in. Oh, there we go. That's a transistor, that's a MOSFET, both in the same package. So you could quite easily get your transistors and MOSFETs mixed up. This MOSFET's a T470, and that transistor was a TIP 41 or a TIP 42C. So vastly different devices, but in the same package. That's something else that can fool you guys. You can get stuff like this, for example. The TO92 small transistor. That's not always a transistor. When I was a kid, I was building little radios with a part called an MK484, which is literally like an AM or an FM tuner IC in a TO92 3-pin package. Over here I've got a drawer full of shunt regulators, TL431s. Let me just see if I can find them. Yep, here they are. Now these are pulled from circuit boards, so they've got slightly shorter pins on them, but it's the exact same package. There you go. So you can't just look at a package of components in and say, hey, that's a transistor or that's a MOSFET because it looks like that. Some things you can, if you see a resistor, that's not going to be something else. If you see a pot, there's a chance it could be something else. There are things that look similar to pots, like rotary switches, which are just switches with a lot of positions. Right? Not a pot. But there are a lot of components, and also capacitors, like you're not going to find something else that looks like a capacitor that's not a capacitor really, but well, you can with some of the small types of capacitors. So anyway, I digress, I'm talking too much. MOSFETs, transistors, resistors, diodes, capacitors. I think basically everyone's already going to know what an LED is, a light emitting diode, but might as well just show you a box full of random different sizes and styles of LEDs, different colours. Another box of them. So those are light emitting diodes. They only let power flow one way too, like their name suggests, diode, but they emit light. They don't just act as diodes. What else could I cover that's basic? I think we'll do inductors. So an inductor can refer to a lot of different things, anything from a choke to a ballast to a transformer, but traditionally it's a two-terminal device. This is two inductors in one. But basically an inductor is also an energy storage device like a capacitor, but where a capacitor will be leading the phase edge by 90 degrees, the inductor will be falling by 90 degrees. What I mean by that is if you put power on a capacitor and take the power away from it, the capacitor just holds the power, and if you stick it on your tongue, you'll get a zap. Until you put a load on it, the power doesn't leave the capacitor. Well, it does have self-discharge, but anyway, that's for something else to talk about. With the inductor, if you stick power in here, the second you release it, a kickback voltage, usually a lot higher than the input voltage, comes flying back out. And you know, if it's high enough and the terminals are close enough together, it will even arc across. So they both store energy, but the thing with an inductor is you can also use it to limit current. So you can boost current, limit current. You can do all sorts of amazing things with inductors. That's really going to be a video for another topic, because I'm going to have to show all different styles of inductors, like different styles of transformers, chokes, ballasts, inductors themselves, and then the different styles of chokes, like is it for low frequency, is it for RF? Yeah, there's so much to go into there, but those are what coils of. When you see a coil of wire usually wrapped around a bit of ferrite or some sort of plastic core, that's an inductor. Just trying to think, because I don't want this video to be too long, and I want people to be able to like learn. Okay, well, these are trimmer capacitors. As the name would suggest or imply to have you think, they are capacitors that you can set a little screw in the middle of, and adjust their value by turning it. Sort of like the resistor adjusts the resistance by turning it. There's a lot of other stuff here that we can go into, but for the sake of this video, it's pointless. You know, integrated circuits have lots of different pins and come in different packages. Some look like a transistor, but on closer inspection, you'll see that it's actually got 5 pins. Integrated circuits, as the name will suggest, is literally a part that could have any number of parts in it. It could literally have millions of parts in the one package. So I can't just pull a chip out and say this is a chip that does this, because all different chips do different things. Just trying to think what else I can go over. Not really a lot to keep things short and simple. I'll pack this up afterwards. Yeah, I mean, there's obviously obvious stuff too that I don't think I really need to show anyone. I mean, everybody knows what a switch is. They come in all different shapes and sizes. I think for basic components, just for now, I think that's a good place to get started. Resistors, capacitors, diodes, transistors, MOSFETs, inductors. You know what else? A transformer. Such a simple device, but we can put a different ratio of windings on these two cores, on these two bobbins, and we can have 240 volts coming in and say 12 volts coming out, or vice versa. So transformers can step up or step down voltages basically. Nowadays we do that a lot more with little switching power supplies, which again, there'll be videos on that in the future. Yeah, I think that's probably a pretty good start. I think the next video I'll make, what I'll do is I'll make a video covering the components that we've already looked at, but how they have different parameters and how the parameters make those same components have so many different types of the one thing. Like there's millions of different types of capacitors, millions of different types of resistors, millions of different types of diodes, transistors, all of that. So I'm gonna have to make some videos explaining that next, so you guys can understand that, and then we'll progress on to more complicated components. I think another thing that would be good for me to do would just be to get a whiteboard or some paper or something and sort of just draw like just fundamental understanding of how power flows and how it works and that, so that you guys can visualize it for people who are learning, obviously. I'll put something in the title when I upload these videos, learning only or something like that, or beginners only, so that I don't waste people's time that are on my level already or above. Yeah, if anyone's got any suggestions for how I could do this better, other than obviously getting a better camera mount and all that, feel free to let me know, because I want to impress everyone and keep everyone happy. But for now, I'm gonna say that's a quick introduction to some basic components, and we're gonna leave off there for tonight. Tomorrow we'll come back. We'll try this panel meter that I've modified, that doesn't have the accuracy problem fixed, but it has the oscillation problem fixed, and we'll try that in here without a voltage follower and see if it still introduces noise or not. Hopefully that noise problem's fixed now, and we can just use it the way it was intended. Yeah, that's all, guys. Stay tuned, there'll be more to come, and thanks for watching. See ya.